Hey, how is it going, everybody? Welcome to the YouTube channel of Petroleum from Scratch. I am Jaiyesh, and this is Statistics for Energy Engineers playlist. So, in our last video, we talked about measure of your central tendency, and we talked about mean, median, and mode, and when to use which. So, in this video, we will be continuing our discussion, and we will be discussing about measure of dispersion. As in the last video, I said why we need to know the measurement of my central tendency so that I can know my data well. Now, adding after once you know your central point, right, of the data, you also need to know how your data is spread across that central point, right? What is the spread or what is the dispersion of that particular data or distribution, right? So for doing that, measure of dispersion comes into picture, and for doing this measure of dispersion, we will be talking about two terms: variance and standard deviation. So let's start with the variance, uh, and does it how it is calculated and all those things, right? So we will be discussing variance and standard deviation. So let's consider an example first again. Let's consider that we have uh, two different data distributions or two different data sets, whatever you want to say. One one is having your points 2, 2, 4, and 4, right? And the other one is having your points 1, 1, 5, and 5. Now, if you calculate mean for these, for example, mean of this will be 2 plus 2 plus 4 plus 4 divided by 4. So mean will be 3. And for this also, your mean will be 3 itself. So here you can see both the distributions are having same mean, right? This one, for this one it is also 3, for this one it is also 3. But if you see carefully, you will see that these data points are more closely packed towards 3. Means if this is 3 is your mean, this is your 3, this is your x-axis, 2, 4. These ones are more closely packed as compared to these 1 and 5. 1 and 5. So there is a spread in the data, right? Both the distribution are having same mean, but distributions are not same because dispersion is not same. Means the spread is not same. So for calculating this particular dispersion, variance and standard deviation comes into picture. Now the formula of your variance is, let's see the formula of variance and how to calculate variance. It is for a population, and again for population and sample, the formula will change. The population mean is population variance is denoted by sigma square, and formula for it will be x minus your mean value. Let's have a square here, because variance is a positive number always, divided by n, I from 1 to n. So this is your formula for variance, right? And in a similar way, standard deviation, I'm denoting standard deviation by STD, is nothing but your root of variance. So formula will be this only, only root will be added here. Now, if we calculate the standard deviation for these both distribution, let's calculate the standard deviation for these both distributions. So it will be my as my mean is 3, I will be subtracting the mean with these numbers. So for the first one, 3 minus 2 square, right? Again 3 minus 2 square. plus my 4 minus 3, or you can say 3 minus 4 square, plus 3 minus 4 square divided by 4. So for this distribution, my standard deviation sigma square will be equal to 1, right? And for this one, if I calculate, 3 minus 1 is 2, 3 minus 1 is again 2, here again 2, and here again 2. So 2 square plus 2 square plus 2 square plus 2 square. 2 to the 4, 4 4 8, 8 4 12, 16 divided by 4. So your variance for this particular distribution will be 4. So from here itself, by seeing the data, the thing is clear that this is having a more spread as compared to this one. So the point here is, important note here is, more, obviously if your variance is more, then automatically your standard deviation will also be more. More variance standard deviation means more the data is dispersed, or we can simply say spread. So let's create two distributions having same mean. Again, this is your x-axis, let it be your mean. So your first distribution is A, right? And your second distribution is B, having the same mean, right? So this one is your B, and this one is your A. So here itself you can see that the spread or the dispersion of a B around mean is more, right? So for A, your sigma is small, sigma or sigma square both. For B, your sigma is large, and both are having same mean itself. So basically, once you know the central tendency and the dispersion, you can easily visualize how your data is spread, or how your data distribution is there. So for seeing the spread in distribution, we use standard deviation or variance, right? Now coming to the point, delete this one first. So this we talked about population standard deviation, or population variance. Now when we talk about sample, here my formula changes. So first of all, sample variance is denoted by S square. That was denoted by sigma square, right? Sample variance is denoted by S square, and in sample there will be n points, small n points. And my, sorry, I have written it wrong. Sample variance is represented by V square, not S square. My mistake, sorry. And the formula for this sample variance will change. This will be from I equal to 1 to n. Again, your xi, and as we are talking about sample here, so here nu will not be there. Here x bar will be there, right? If you remember from the last session, measure of central tendency 1, we talked about this, right? That sample mean is represented by your x bar, and the population mean is represented by your nu. Here I missed this xi mark, so I'm adding that to the power 2. And in denominator, instead of n minus 1 comes into the picture. And this particular n minus 1 is known as Bessel correction. Bessel correction. And this is your variance, sample variance, and sample STD will be nothing but your under root of your sample variance. So it will be V itself. So when we take under root of this particular term, that will be my sample standard deviation. So here this n minus 1 term comes in denominator instead of n. Why this come, that we will be discussing in the next video. So I hope you guys got an intuition that what exactly is measure of dispersion. So we'll see you in the next video. Until then, bye bye. Happy learning. Have a good time.